हेलो फ्रेंड्स, इन्फिनिटी मैथ में आपका स्वागत है। दिस इज़ डॉक्टर रुचिरा चौधरी एंड टुडे वी विल गोइंग टू लर्न अबाउट सेट थ्योरी which will be mainly about some definitions and basic conceptions. If you have any question or any doubt regarding the set theory, please let me know through your comments and write down it in the comment box. So let's start with the definition. What do you mean by a set? A set is a collection of distinct objects of our perception or thought. Like if I say a collection of good students, is it a set or not? If I ask you, is it a set or not, the answer will be no, it is not a set, because the word good is not defined properly. You may think the students who have got 80% or above are good students, and I may think the students who have got 90% or above are good students. So your collection will be different from me. So the word good should be defined properly in order to become a collection, to be a set. Like for example, if I say S x such that x is an integer, it is a set because by this definition x is an integer. By this definition we can say whether an element belongs to or not belong to that set. So by this definition I can say 5 belongs to S because 5 is an integer, but 1 by 5 does not belong to S because 1 by 5 is a fraction and it is not an integer, so that does not belong to S. So this is a set. Sets are usually denoted by capital letters like A, B, C, etc. But there are some standard notations for using some sets of numbers, like capital N is used for set of natural numbers. Capital Z is used for set of integers, but capital Z plus is used for set of positive integers. Capital Q is used for set of rational numbers. Capital Q plus is used for set of positive rational numbers. Capital R is used for real numbers. Capital R plus is used for positive real numbers, and capital C is used for complex numbers. Set can be written in two different ways. Like that, if we want to write set of integers, then we can write it in this way: Z equals to x such that x is an integer. But this set of integers can be written in another way. Like if we want to write this x such that x is an integer, then this is coming from minus infinity dot 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 minus 3 minus 2 minus 1 0 1 2 and dot 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 going to plus infinity. This is an infinite set. Again, if you notice this set is x such that s equals to x such that x is a prime less than 10, then if we want to write this set in another way, then this set will be equals to 2 3 5 7 this. So a set can be written described by listing all the elements which are separated by commas and are written within the second bracket, or it can be written this way. This is the definition: x such that x is an integer, or x such that x is a prime less than 10. So these are the two different ways by which we can describe a set. So now I am coming to the definition of a subset. In case of subset, there is a bigger set, and when you get a smaller set from that bigger one, then smaller set is said to be the subset of the bigger one. Like that, let S be a set. A set T is said to be a subset of S if X belonging to T implies X belonging to S. That is, each elements of T are the elements of S, and this is usually denoted by T subset S. That is, there is a bigger set and the subset is the smaller one from that bigger set. This is T and this is S. This is the Venn diagram of the subset. So, in case of number system, we write it as a set of natural number n is the subset of the set of integers, that is Z, and Z is the subset of set of rational number, that is Q. Q is the subset of set of real number, that is R, capital R, and R is the subset of set of complex number. Because set of natural number is the set of positive integers, but set of integers are the set of integers includes set of positive integers also, as well as set of negative integers, and Z is a subset of set of rational number because all the integers are included in the rational numbers, and Q is the subset of set of real numbers, and set of real numbers are the subset of set of complex number. Now there are two important sets that are null set and universal set. Null set is generally denoted by phi and is written as this. So there is nothing in the null set, and universal set is generally denoted by capital U. All the sets are considered to be the subset of that universal set. I am coming to the algebraic operations on set. There are two algebraic operations on set, that are union and intersection. So at first I am coming to union. Union of two subsets A and B is a subset of the universal set U and is generally denoted by A union B and is defined as X such that X belongs to A or X belongs to B. For example, if I say A is like that A, B, C, D, and B is D, E, F, then A union B will be equals to A, B, C, D, E, F. So you take all the elements from A and B and you will get A union B. In Venn diagram it is like that. If A is the set A this, B is the set this, then A union B will be this region, and this is the subset of the universal set U. Our next operation on set is intersection. Intersection of two subset A and B is a subset of the universal set U and is denoted by A intersection B and is defined as X such that X belongs to A and X belongs to B. That is, if I say A is A, B, C, D and B is C, D, E, F, then A intersection B will be only C and D, that is the common elements of the A and B. In Venn diagram it is like that. If A is the set this and B is the set this, and only their common portion will be A intersection B, and this is the subset of the universal set U. Now I am coming to complementation, that is the complement of a subset A is the subset of the universal set U and is denoted by A complement or A complement AC, and is defined as A complement equals to X belonging to U such that X does not belong to A. That is, you are taking the elements which are not included in the set A. That is, you are taking the elements from the outside of A. In Venn diagram it is read like that. If the set universal set U is this and A is this, then A complement will be this outside portion of A, that is A complement or A complement. And if, for example, if I say A is equal to A, B, C, D, and U, universal set U is equals to A, B, C, D, E, F, G, then A complement is equal to E, F, G. That is, the elements which are not included in the set A, and you are taking the elements E, F, G from the universal set U. There are three important properties regarding complementation. First property, A union A complement equals to universal set U. That is, if you consider A to be our earth and A complement will be the region which are outside our earth. So you are taking the elements from A, and also you are taking the elements which are from outside of A. So that A union A complement will be equal to U, that is the whole universe. Next property, A intersection A complement equals to phi, because clearly there is nothing in the common of A and A complement, so the set will be phi. And third property is A complement whole complement equals to the set A itself, because you are taking the complement, again you are taking the complement of that complement, then the A will be returned in that as a result. Now there are two important laws called De Morgan's laws, which is like that A union B whole complement is equal to A complement intersection B complement, and A intersection B whole complement is equal to A complement union B complement. So this union is converted to intersection and this intersection is converted to union. These are the De Morgan's laws, and these laws is mainly used to solve the problems related to set theory. Okay, these are the main basic ideas of set theory. If you want more topics related to set theory, please let me know through your comments. In my next video, I will solve some problems related to set theory, and so stay connected and go to my next video.